In this video, we will explore the concept of apparent weight through an elevator example.
So, in this first picture right over here, I'm going to assume that the velocity is equal to 0. Or another way to think about it is the elevator is stationary. And everything we are going to be talking about in this video, I'm talking about in the vertical direction. That's the only dimension we're going to be dealing with. So, this is 0 meters per second in the vertical direction. Or another way to think about it, this thing is not moving. Also, this may be somewhat obvious to you, but its acceleration is also 0 meters per second squared. Then let's say that I'm in this elevator, and I press the button, so the elevator begins to accelerate upwards. Let's say the acceleration is 2 meters per second, and I'll use the convention that positive means upwards, or negative means downwards. We're only going to be operating in this one dimension. I could write 2 meters per second times the j unit vector, because that tells us that we are now moving. That tells us that we are moving in the upward direction, and let's say we do that for 1 second. So we do that for 1 second, and then at the end of 1 second, we stop accelerating. So the mass of the individual in the elevator is 60 kilograms. So what is the force of gravity? Or another way to think about it, what is the person's weight? In this picture, it's mass times the gravitational field near the surface of the Earth, the 9.8 meters per second squared, and then negative tells you it's going downwards. So you multiply this times 60 kilograms. The downward force, the force of gravity, is going to be 60 times negative 9.8 meters per second squared. So negative 588 newtons. And I could say that that's going to be in the j direction. We're going to assume that the gravitational field is roughly constant, although we know it slightly changes with the distance from the center of the Earth. But when we are dealing with the Earth's surface, we assume that it's roughly constant. And so what we'll assume, we have the exact same force of gravity there. And of course, this person's mass does not change depending on going up a few floors. So it's going to have the same force of gravity downwards. Now we're going to be talking about apparent weight, or W prime. This equals mass times the force of gravity plus or minus acceleration. In this case, the elevator was moving at 2 meters per second for 1 second. Therefore, we were moving at 2 meters per second squared. That is the acceleration. So, in order to find your apparent weight, you will multiply mass, or 60 kilograms, times the quantity of acceleration due to gravity, 9.8 meters per second squared, plus the acceleration of the elevator, 2 meters per second squared. When you multiply this out, you get 708 newtons as your apparent weight. Can you feel it now?